This is the morning test review worksheet over Chapter 5 and 6 in slope fields. So number 1, consider the differential equation given by dy over dx is equal to xy over 2. Sketch a slope field through the indicated points. So we can make some observations here. Is that when x is 0, then we know this our slope will be 0. And when y is 0, we're also going to get 0 as well. So what that means is on the y-axis, when x is 0, we know that our slope will be 0. On the x-axis, where y is equal to 0, we also know that our slope will be 0. So these will be the easier ones to find. Here, the ordered pair here is 1, 1. So if I plug 1 and 1 in for x and y, I get 1/2. So slope of 1/2. And if I plug in 2, the ordered pair 2, 2, I'll get slope of 1. And if I plug in ordered pair 1, 3, I'll get 3 over 2, so 1.5. And these here are simply going to be the negative versions of these slopes here. Okay, so we've sketched our slope field through those indicated points. Part B, find the particular solution to y equals f of x for the differential equation with the initial condition that f of 1 is equal to 1. So we first need to go through and find the general solution. First step, separate the variables. Get the y's on the left, everything else on the right. So dy over y is equal to 1/2 x dx. Take the integral of both sides. The left side will be the natural log rule. So 1 over u is natural log of u. So 1 over y is equal to natural log of y. On the right side, we go through power rule. 1/2 times x squared over 2 plus c. So x becomes x squared over 2. And then the next step is we have to solve for y, but y is inside the natural log function. So to get it out, we have to raise both sides with base e. So e to the ln of y is equal to e to the x squared over 4 times e to the c. And we know e to the c just represents a constant, so we pull that in front. Y is equal to c e to the x squared over 4. Initial condition is 1, 1. So plug 1 in for x, plug 1 in for y over here, and then we solve for c. So e to the 1/4, we divide that to the other side. So we get c is equal to 1 over e to the 1/4, which if we bring it up, it becomes c is equal to e to the negative 1/4. And if we plug this back into our general solution, to get our particular solution, we get y is equal to e to the negative 1/4 times e to the x squared over 4. And when we're multiplying bases, we can simply add or subtract exponents. So negative 1 plus x squared, or x squared minus 1 over 4, e raised to the x squared minus 1 over 4 will be our specific solution. Okay, part C says write the equation for the tangent line to the curve through the given point 1, 1. Through the point 1, 1. So our derivative formula is xy over 2. So we simply can just plug in the ordered pair into our differential equation, our differential function, which is also our slope finding formula. So simply up here, we just look xy over 2. We plug in our ordered pair 1, 1. In return, when we plug in, we'll get the slope. So plug in 1 and 1, and for x and y, we get 1/2. That's our slope. The ordered pair is given to us. So we have our point, we have our slope. We can just plug it into point slope form. So y minus 1 is equal to 1/2 x minus 1. And now, and then add 1 to both sides, we have our equation. Now we can use the tangent line equation to estimate f of 1.2. So we just plug 1.2 in for x, and we get 1.2 minus 1, which is 0.2 times 0.5 plus 1, we get 1.1. All right, number 2, Newton's law of cooling. A container of hot liquid is placed in the freezer that is kept at a constant temperature of 20 degrees. The initial temperature of the liquid is 160 degrees. After 5 minutes, the liquid's temperature is 60 degrees. How long will it take for the temperature to decrease to 30 degrees Fahrenheit. So with Newton's law of cooling, the differential equation is the change in temperature is directly proportional to the difference between the temperature and the median. So this equation is basically given to us, and we can just go ahead and take this and go through the process to find our solution. Okay. Before we do that, we can also go ahead and identify the ordered pair that we're going to be using. So everything's in terms of time and temperature, time being the independent variable, temperature being the dependent. So we know initially temperature is sitting at 160 degrees. After 5 minutes, 60 degrees. And then we're trying to find out the time that passes before the temperature falls to 30 degrees. So we can now begin to work with our differential equation. So we separate the variables. Let's bring the y's to the left, everything else to the right. So we have dy over y minus 20 is equal to k dt. Take the integral of both sides. We can go through u substitution here. U is equal to y minus 20. du over dy is equal to 1. dy equals du. So the integral of du over u is simply natural log of u and natural log of y minus 20. So we're not going to produce any leading coefficient or any negative to keep track of. It will simply just be natural log of the absolute value of y minus 20. Integral of k is a constant, so the integral of a constant is a constant times a variable plus c. Right, so we're ready to try to get y by itself. So to do that, we have to get rid of natural log. So we're going to use the properties for exponential function e to the x. So raise both sides with base e. So we get e to the ln of y minus 20 is equal to e to the kt times e to the c. E to the c represents a constant, so we pull that out in front as a coefficient. And the left side simply reduces to be y minus 20. Okay. From here, we want to begin to solve for, find our particular solution. So we're going to find our c value, and we need to find the k value. We can use the first order pair to solve for c, and then we can use the second order pair to solve for k. So 160, we can plug that in for y. 0, we can plug that in for t. So we can solve for c. 160 minus 20 is 140. E to the k times 0 is e to the 0, which is 1. So c is 140. So our c value is 140. We can plug that back into our equation to get closer to our goal. So once we're here, now we can look at the second order pair and see if we can plug in and solve for k. So 60, plug that in for y. 5, we'll plug that in for t. And let's see if we can simplify and solve for k. 60 minus 20 is 40. 40 is equal to 140 e to the 5k. We want to eventually solve for 5k, but first let's get the e to the 5k by itself. So let's divide both sides by 140. 40 divided by 140 reduces to be 2/7. So we have 2/7 is equal to e to the 5k. Now we want to bring this 5k down from its current position, sitting up as an exponent. So in order to bring it down, we have to introduce logs to both sides so that we can use log properties to bring that exponent down. Okay, so we take the natural log of both sides. The 5k can come down in front. Natural log of e is simply 1, so that cancels out. Last thing to do to solve for k, divide both sides by 5. So k is equal to 1/5 natural log of 2 over 7. Okay, so we have our k value, we have our c value. Now we can write our specific equation. Y minus 20 is equal to 140 e to the 1/5 ln of 2/7 t. Okay. So now we're ready to plug in our final value. We want to find out the time it takes for the temperature to fall to 30 degrees. So replace 30 in for y, and we simply solve for t. So 30 minus 20 is 10. This entire expression we want to get by itself first, so divide both sides by 140. We get 1/14 is equal to e to the 1/5 natural log of 2/7 t. Exponent has the variable which we want to bring down, so To bring it down, we're going to take the natural log of both sides. Okay, once we do that, natural log of v will go away. 1/5 natural log of 2/7 t will come down. Now we can deal with this. So divide both sides by 1/5 natural log of 2/7, or that same thing as multiplying by 5 to the other side, dividing by natural log of 2/7. The rest can go in your calculator. So we get t is equal to 5.533 minutes later.